Okay, this is Chapter 2, The Internet of Things is Changing How We Live, Part 2. So, new challenges created by IoT. Security. How do you keep the bad guys out if you enable the Internet of Things for your personal and professional life? Privacy. How do you protect your family's identity and privacy data from theft or unauthorized access that can lead to identity theft? Interoperability and standards. How well do IoT manufacturers and ASP developers ensure that devices communicate securely? Legal and regulatory compliance. What role do the international, federal, and state levels contribute toward legal, tax, and regulatory requirements regarding IoT-related business transactions that involve payment for goods and services? E-commerce and economic development issues. What are the economic rules of engagement for conducting business on the World Wide Web? How is IoT connectivity and information sharing to be deployed globally? Security challenges of IoT devices. They're deployed in large quantities, such as sensors or consumer items. They're ubiquitous and can have wide reach into the user or household population. Devices that are not maintained or updated allow vulnerabilities. Indeed, several years ago, there was a brand of baby monitors out there that was being hijacked by someone who was making them make sounds, redirecting the camera, and so forth, all because the users who had bought these devices didn't realize they or forgot that they were connected to the internet, and they left them with the default password and never changed it. That was written up in Computer World about 4 or 5 years ago. Upgrades can be difficult to distribute and deploy, and no owner visibility of how the device connects to the internet. Often owners don't know how it's connected to the internet. And a lot of times they're not physically secure. They can be moved around. Of course, an IoT device like our smartphone is really not physically secure at all. And lastly, um, they can capture readings and measurements out in the open if they're not secured. Privacy challenges. The Privacy Policy Statement, or PPS, the actual legal definition of the user's privacy rights as documented in the manufacturer's privacy policy statement. Definition of data, metadata, or analytical data use and rights. Actual definition that defines what data, metadata, or analytical data are and what they may be used for, and if permission is required by the user for the use of these data. The ability for a user to provide consent to a manufacturer or application service provider's privacy policy statement. Users must be able to read the statement online and accept or decline the privacy policy's terms and conditions. Once you provide consent, it's difficult to remove that consent. Determine the domain of policy. If you permit geolocation tracking of you and your smartphone, and another application service provider uses that information about you and where you go, is that infringing on your privacy rights? New areas of privacy concerns. How do we address the data source and data collectors' rights and use of data? Is there a happy medium that includes de-identification of private data with no ability to link those data to a person? How will an individual or business even know what a good privacy posture or preference is? Will the current social context and acceptable behavior extend to the Internet of Things? And can we develop privacy by design with a set of core requirements and put in place a standard implementation of privacy for all of the Internet of Things? Interoperability and standards. The Internet Engineering Task Force, or IETF, ensures interoperability and standards can be pursued for IoT solutions. Interoperability has significant financial impacts if not properly addressed. If devices cannot communicate with each other or on different networks, that could create a real problem and can create significant and large financial issues. The goal is to bring the cost of IoT devices and supporting applications down so they are affordable. Interoperability and standards challenges. Some manufacturers want to design and deploy proprietary IoT devices and solutions. A strategy to lock in early adopter customers and businesses to their own solutions. This creates technology silos that don't permit for information sharing and requires a gateway or intermediary solution to share info. Cost factors to implement functional, operational, technical, and security capabilities into Internet of Things devices and applications. The time to market risk. First to market advantage does exist for the global scale Internet of Things device marketplace. Vendors and manufacturers have been playing this game since technology, though, was first invented. Technology outdated risk. But before we talk about that, we really need to talk again. How fast you get ahead of the interoperability and standards curve is based on where most of the user and business community is regarding the use of proprietary or open standards based IoT technology deployment. With regard to that technology outdated risk, IoT vendors, manufacturers, and software developers each take risks when developing IoT solutions and products without interoperability and standards definitions being defined and adopted. And there's a void in interoperability and standards for IoT devices, and that can create an environment of bad IoT devices, which creates a lack of communication and information sharing. Legal and regulatory issues, proper handling and protection of sensitive data. Privacy data is subject to privacy laws of the state that you live in, as well as the state that the IoT hosting company resides in. IoT vendor or solutions provider are required to adhere to security control requirements and data protection laws. Who is collecting the data? Who is collecting behavior patterns? Are they selling the data? Do they have a right to sell it? Is there liability associated with that data? E-commerce and economic development issues, infrastructure resources. Foundational to the development of the IoT, the communication infrastructure and broadband internet network are needed within that country. This is the foundation for IoT device connectivity and communications in a global marketplace. Foundational investments. Countries seeking to invest in critical infrastructures may be able to leapfrog past other countries that are struggling with regulatory and legal issues in regard to accelerating deployments. Technical and industry development. New skills are needed to bring new technologies and economic solutions to bear using the internet and the Internet of Things as a key economic driver. As Internet of Things technology and industry interoperability and standards mature, so will Internet of Things device deployment and user and business adoption. And lastly, policy and regulatory definitions. Countries and emerging economies are positioned to create and implement policies and regulations to help ensure that security and privacy become part of the deployment. In summary, the evolution of the Internet of Things we talked about it from the late 1990s to the present, the impact that the Internet and the Internet of Things have had on human and business life, how bricks and mortar businesses transform into e-business models with e-commerce and an Internet of Things strategy, how IP mobility is driving the Internet of Things to include both personal and business environments, and the new challenges created by the Internet of Things.